For this lesson, we're taking a look at triangles, and we're discussing the idea of similarity and congruence within triangles. A little bit later, we're also going to take a look at some corresponding parts. Now, right now, these two triangles that we're looking at, triangle ABC and triangle DEF, we'd probably say that these two triangles are at least similar. Right now, it looks like that they have the same general shape, 90-degree angle here for angle D and a 90-degree angle here for angle B, but we could probably go one step further and say that these two triangles are probably going to be congruent as well, as they look like they're about the same size and shape. That's a key difference that we want to take note of. The idea of similarity in triangles is that they have to have the same general shape. So if I wanted to, I could draw another triangle here. And while it looks like it's the same shape, it's definitely not the same size. So this would be triangle XYZ would be a good example of a similar triangle, but it's not the exact same size. So triangle XYZ, triangle ABC, and triangle DEF would all be considered similar, but only triangles ABC and triangles DEF would happen to be considered congruent in this case. Another idea we're looking at here is corresponding parts for the triangles. Now, triangle ABC and triangle DEF, since they're congruent, we can take a look at their sides and their angles and determine what parts match up and would be the same angle measurement and the same side length. Now, I think a good way of doing that, from my perspective, is to rotate the triangles so that they match up a little bit easier. For instance, I'm going to take angle D here and rotate it so that it matches up and looks very similar to angle B. So one way that we can go about matching angle D to angle B is by turning and flipping the triangle. Now, the first way we'd probably turn it is we'd move F this direction. So then the triangle would kind of look like this after the first term, but that's not going to match exactly with what we have here for triangle ABC. So what we can do then is called flipping it, and we're going to take the triangle and flip it the other direction. So then it's going to match a little bit more like that, which if we take a look, it's going to look very similar to what we already have here. So if we redraw the triangle, matching the image we get after we've flipped and rotated it, we know that we moved F up, so F was here, but then we flipped it on the x-axis, so now F is over here. So that means here is where angle F ended up at. At the same time, when we rotated F up, E went up here. So that means E still stayed up top here. At the same time, as we rotated it, D moved to this spot, and when it flipped, D stayed down here. So now we have our two triangles. Based on the fact that we have them flipped and rotated so that they match, we can now say that angle A equals angle E. We can say that angle C equals angle F, and we can say that angle B equals angle D. Now, my personal preference is to name all angles using 3 letters, but since we have separate angles here and each letter is a point on the triangle, we can get away with naming them using single points. We can also name corresponding sides. So we can come over here and let's pick a different color. I can say that AB equals ED. I can say that CB equals FD, and we can also say that AC is equal to EF. So we now have our sides, and over here we have our angles. So that's a little bit of an example of how we would go about taking a look at similar and congruent triangles and finding their corresponding parts.